It's the moment we've been waiting for. How is it that a function call is actually evaluated in Python? What is this wild, mysterious magic going on behind the scenes? Well, in this lesson, we're going to unravel the details and the mystery behind function call semantics. What are the steps that are taken in order for Python to take a function call and fully evaluate it? So let's jump right back to the example we looked at in the previous video where we introduced function syntax. If you're unfamiliar with function definition syntax, go watch that video. Be sure you didn't skip over it. And in that video, we introduced a function named myMax. It's a simple function that implements, effectively the logic of a max function. You give me two integers and I'll give you back the larger of the two. We've got our function definition here. I've changed just slightly the usage that comes after this function definition in order to set up an example that will help us think through exactly how this function is evaluated. This function call that we see here on line 14 is evaluated by Python in memory when we reach that point. Right? So if you think through this program, I'm guessing you already know what the output of this program is. We are declaring a function named myMax. So we'll need to look at what happens in memory when we declare a function. And then we declare a few variables. X is 6, Y is ultimately going to be bound to a value of 7. And then we reach our function call expression. And that result is going to be assigned to Z. Well, we need to figure out what happens when this function call is evaluated. What's going on in memory to make this all work and keep track of where we are in our program? Well, that's what we'll get into. Ultimately, if we are comparing 6 and 7, 7 is what's going to result through some incantation of steps, and 7 will be bound to Z, and we expect 7 to be printed. If we want to go ahead and convince ourselves that this program just works, let's try running it. So I'm going to open up a terminal and run my program, Python m, and lessons.function def is the name of my module. All right, so there we go, 7. All right, not the most mind-blowing of programs, but it will help us trace through the exact steps we need to know in order to evaluate this program. Okay, well, we're going to be relying upon our memory diagrams, our stack heap diagrams, and we're going to be focused on the call stack. And finally today, we're going to know why it's called the call stack. Because of function calls, they're going to have a very significant impact on what we do in memory. So let's go ahead and set up the basis of our environment diagram in order to begin processing this program. So we know that our environment diagram is going to have an area for stack memory, and our stack is going to have a globals frame in it, right? And so our globals frame is going to contain any variables, or as we'll see, function definitions that we encounter in our global space or scope, I should say. Now we are also going to need a heap once we have function definitions. And this will be just we'll make minor use of this for now. And as we learn about more complex objects and types, we'll make more use of the heap later. And we also need a space for output, of course. For the purposes of just fitting this all in the window we have available to us, I'm going to rate my output when we get to it down here. Okay. Right, we know the output is going to be 7, right? But what happens? How do we actually reach that evaluation? And what's going on in memory? How do we keep track of these things? So the first thing we see is a docstring on line 1. There's nothing for us to do with a docstring, right? Next, we see a function definition. And when we reach a function definition, we're saying, here is what we mean by the name myMax. So myMax actually becomes a name that's bound in globals, right? So myMax is a variable. It's not really a variable, but it is a name that's bound in our globals frame, right? It's a function definition, and it's going to be bound to its implementation, right? So we're going to draw an arrow to the function that's defined on lines 4 through 9 in our program. Right, so in our code listing, notice in our margin here, we see that this function definition exists on lines 4 through 9. And so now what we're saying is after the interpreter has encountered this definition, myMax, the identifier, the name, whenever we refer to this name in the future, it's going to be bound to the function whose definition, whose instructions, whose recipe is found on lines 4 through 9. Okay, so we've encountered that. Great. We don't need to do anything about this, right? That, like, when you encounter a definition, nothing happens, right? This is like seeing a recipe. You're not following the recipe yet. We won't go and worry about these instructions until we actually call this function. We haven't done that yet. So all we're doing is we're saying, okay, we encountered a function definition, and that definition is found on these lines. Once we get to a call, we'll worry more about this. Next, we reach our friend, the variable declaration statement. So we're declaring a variable named x and assigning it a value of 6, right? So 6 is going to be assigned to x, nothing to do there, just an int literal. Here we see an int expression, 5 plus 2. We know that we need to evaluate that fully on the right-hand side of our assignment operator before we assign it to our variable y. So 5 plus 2 is 7. 7 is going to be assigned to a variable named y. Right? And I should make myself a little bit more space here. All right, and now the moment of truth, what we've all been holding our breath and waiting for. What happens when we reach line 14 here, when we reach this expression? All right, I should say this statement, this variable declaration statement that contains the function call expression where we're calling the function myMax. All right, well, this is where we need to be careful, slow down, pump the brakes just a little bit. We already know intuitively how this works, but let's talk very specifically about the concrete steps Python will take as it evaluates this function call statement. Okay, so the first thing that it's going to do is ask, do we even know what myMax is? Is this a function that's been defined? And we're going to look in our current frame. Well, the current frame that we're operating in is the globals frame. Right? We haven't seen another frame yet, but we're about to. In the globals frame, we have a name myMax there. Great, we know what function this is. Now you know that if this were just the function max, it would be defined in our built-ins, which we're not diagramming, but it would exist there too. This is myMax specifically, right? This is the name that we're referencing in this function call expression, myMax. And we know what that is. It's bound to the function on lines 4 through 9. Great, so we know that we're talking about this function here, right? All right. So I'm actually going to keep track of these steps in some notes because I think it's worth having these notes such that you can come back to them when you're working on diagrams of other code listings. All right. So the first thing that we're going to do is prepare for a function call. All right. When we encounter a function call, we're going to prepare for it. So before we jump into that other function and go do the steps of its body, we need to prepare for it. And the first thing we're going to do is what we just did. Does the name even exist? So check for name being defined. If we had a misspelling here, if we just did myMax without the underscore or had 2 X's or something, or it didn't match in any way, we would have encountered an unknown function when we tried to call it, and we would have had an error. We wouldn't have known what to do, right? The next thing we're going to do is we're going to fully evaluate the arguments. So fully evaluate arguments. So remember, our arguments to a function call are expressions, right? So let's jump back to our example in order to remind ourselves what we're talking about here. All right. So our function call has these 2 expressions, right? So x comma y, these are our arguments, and x is an expression. It's a variable access expression, right? So we need to go figure out and evaluate x. Well, what is x? So we look in our frame and x is going to be 6, right? So if I were to write out what does this sort of next step kind of look like, just as sort of scratch, this wouldn't really appear in our diagram, but we would say, okay, we're about to call myMax, and we fully evaluate our first argument here, x, to be 6, and our second argument here, y, to be 7. Right? Those were the values that were bound to those variables. Okay, so we've completed that second step. We've evaluated our arguments, right? Now we need to check to be sure, do our arguments and their types actually match up in the number and type with our parameters? Well, 6 is an integer, and that's going to correspond to the parameter a of our definition, and 7 is an integer, and that's going to correspond to the parameter b of our definition. So in this case, yes, we've got what appears to be a valid function call. We are providing the correct number of arguments to this function, which declared 2 parameters, and the types match up. Great. So we've got our name, we've evaluated our arguments, we've checked our types of our parameters, and all seems good. All right, so this was the third step in preparing for a function call. We're looking for agreement of arguments and parameters. So let's just go make a note of that real quick. So agreement, I'm going to leave this in the prepare phase of the call. So we're preparing for the call. Agreement between args of the function call and params of the function definition, right? So as long as these three conditions are met, we're able to fully evaluate our arguments, and that's okay. We know that the function exists, and we've checked for agreement. Then we're ready to make the function call and actually carry out the function call steps. So next, what we're going to do is we're going to establish a frame for the call. All right, so we're going to establish a frame for our function call. What this means is we're going to set up some space on our call stack that's separate from our globals frame. So we're going to have a new frame, right? And this is going to give us some working space to carry out the instructions of our function. Now let's jump back to our example and look at what this means in the context of this example. All right. Okay, so we've checked everything out. We're prepared for this function call. And now what we want to do, and actually I'm going to leave 6 and 7. I'm going to leave this sort of scratch here, my max 6, 7, all right? Because we're going to need those arguments to prepare the frame and set up our function call frame. All right. So now we're going to create a new frame for this function call. Our globals frame is the one that exists with our variables x and y and my max. And now we're going to set up a frame for this specific call to my max. All right. So now we're going to call my max, and we're going to set up a frame for it. As just a general piece of advice, when you're setting up a new frame, to avoid literally boxing yourself in, I would encourage just extending down the left side of your box, because we don't yet know all of the variables we might need inside of this frame in order for this function call to complete. So what we're doing is we're setting up some space for to keep track of all the details we need to know to carry out a function call. One of the first things I did was I labeled this frame with the function call that we're evaluating, right? So we're making a call to my max, okay? And the next thing we're going to do is we're going to keep track of where did this function call come from? What line did we encounter this function call on, right? So we're trying to process this expression right here, and that occurred on line 14. So I'm going to go ahead and set up a return address, right? And we'll make a note of what this means in just a moment, of line 14. Right? So my return address is the line I'm going to go back to once this function call is evaluated, right? So our goal is to evaluate this, boil that down to a single integer, and then carry on as if we are working as we already know how this program would continue. Okay, so we've named our frame, we've set up our return address, which is keeping track of the line that the function call was encountered on. And now what we want to do is pass in our arguments. We're going to pass our arguments to our parameters. Well, we see that these parameters are defined in our parameter list. And I mentioned in the previous lesson that a parameter is a lot like a variable declaration. It's a variable that's declared only inside of this frame. So let's set up those parameters. We're going to have a parameter A and a parameter B. And notice that these are effectively variables that live inside of the frame for this specific function call. Okay, so what's A going to be? Well, this is what we call parameter passing. We're going to take the argument and assign it to, or pass it to, the corresponding parameter. So 6 is going to be assigned to A, right? It's almost as if when we made this call, we're saying A is assigned 6, right? So I'm going to go ahead and enter 6 for A. And 7 is going to be passed to B in the same way. It's as if we're saying B is 7. Now you would never actually write that in this example. This is happening behind the scenes when the program is being evaluated. Okay, so 7 is assigned to B, and we've passed our parameters in. All right. Now, once you've set up the name for your frame, set up some space in your stack for this call, set up your return address, passed in your parameter values, you're ready to make the big jump. We're going to jump into the function definition, into the body, and start evaluating it at its very first line. All right. So now we've fully set up this frame, and we're going to be working starting with this line on line 5. All right. But the current frame that we're going to be focused on when we start asking, do we know what A is? Do we know what B is? Or if we were asking what X or Y is, we're changing frames. We're saying, okay, for the purposes of evaluating this code, the current frame that we're working with is this one. Right? And this is where we're going to look up what the name A means, what the name B means, and this is where we're keeping track of what we're currently working on inside of the most recent frame we added. Okay, before we continue on here, let's go ahead and make some notes and recap what we did in order to reach this point in our notes. All right, so we're going to establish a frame for a function call. What were our steps? We set up some space, a space on stack below where we were previously working, labeled. And we're going to label this with the name of the function, all right? And the second thing we did was we wrote down in frame return address, which we're going to label RA. All right, so this is the RA. We're going to add a box RA in the frame that we are setting up, which is the line where call originated. Right? So you can think of this kind of like a bookmark that we're going to go back to once our function call evaluates. And so our return address is the bookmark we're dropping, the place where we need to return back to once we finish evaluating this function call. And the last step that we made here was we copied our arguments. And more formally, I'm going to put quotes around this copy. We passed our arguments to params. So to our parameters. And I might just make a note that parameters are variables in our frame. All right. So we've got our sequence of steps that we followed in order to get into this function definition, into the function body, right? So after we established all of this, the next thing we did was we jumped into the definition. And let's continue on from there. Let's keep looking at how do we finish this out and keep evaluating this program. So we are paused on line 5. On line 5, we encountered the document string for this particular function. That's just describing it. There's nothing for us to do here, nothing special. That's just for informational purposes. And then we reach an if-then statement. Right? So this statement is one we've encountered before, and we're just asking, what is the evaluation of this Boolean expression? Is A greater than or equal to B? So the first question we need to ask is, what do we even mean by A? Well, our current frame is this one. It's the lowest frame on our stack that is yet to return. So whenever we're evaluating a function, we're always going to first look in the current frame that we're working with in memory. And here we see, okay, yeah, sure enough, A is bound to a value of 6. So this is asking 6 greater than or equal to, and B is another variable access. So we look in our current frame, we look and we say, okay, B is bound to 7, 6 greater than or equal to 7, true or false? Well, that's false, right? So this is false. And what happens when we evaluate our Boolean test to false in an if-then? Well, we jump to the else branch, supposing there is one. And in this case, there is. So we reach this else, and now we encounter a new type of control statement. Right? We haven't actually encountered a return statement yet and discussed what this very important piece of syntax means. You'll find return statements inside of your function definitions. And we'll talk a little bit more about the specifics of this, but the gist of what this statement is doing is it's saying, okay, we've reached a conclusion here. We've reached the point of being able to respond to this function call with some value. And here's the value we want to return back. So this is going to initiate another sequence of steps that we need to be very careful of in order to understand what happens in memory and how this program returns back to where the function call originated with some result. All right. So let's break down what happens at this line here. So we've reached return B, and this is a return statement. The first thing we need to do is fully evaluate this expression. Right? Now I want to make a note about this expression because it's very important. You'll notice that it's returning B. Well, we ask ourselves, what data type is the variable B defined to be? Well, it's an integer. And it's no mistake that that corresponds to what we specified this function would evaluate to. So whenever you have a return statement, the expression that follows the return keyword must match up with whatever that function defined it would return, right? So if we're saying, I'm going to return to you an integer, and that makes good on this contract saying this function is going to result in an integer value, okay? If we had a function that declared it was going to return a string, we would need a return statement that also returned a string value inside of that function definition, right? Okay, so we need to fully evaluate this. So this is the same as saying return 7, right? So we fully evaluated this expression that's part of the return statement. And now what do we do with this value 7? Right? Well, this is the return value for this function call. We're going to keep note of this in our frame, and I'm going to add an entry here, RV, for return value, and we'll make a note of that on our notes in just a second. It's going to be 7, right? It's what we evaluated this function to. Okay, well, what do we do with that value 7? Well, we wrote down and we kept track of this return address, right? This was the line that got us into this function call in the first place, right? This is where the function call evaluated. So it's as if we're saying, take the 7 and return it back to, in this case, line 14, right? So line 14 was where this function call originated from. This is how we got into this function definition in the first place. And now what we're saying is this whole function call expression is evaluating to 7, right? So we've completed this process. And this frame is now completed. And our current frame, once we've returned our value back to the return address, it's going to go back to being in globals, right? So now we're back in the globals frame. And what we're saying is, okay, let's set up the Z variable and assign it a value of 7. Okay. So now line 14 is completed and we've finished returning. Before we go on any further, let's make some notes about what we just did to complete this process with the return statement. So the return statement has a few steps, right? The first step is to fully evaluate the expression being returned. Fully evaluate the expression following the return keyword. And I mentioned that return is a keyword because you can't use this word. Return is a special word you can't use as a variable name or a function name or anything else. It's reserved in the Python language and in most programming languages. Return following the return keyword. All right. So we do that, and we're going to keep track of this as the return value, which we're going to label as RV in our diagrams. All right. So that return value tells us what this function call evaluated to. And then what do we do with that? Well, then what we do is we jump back to where the function call originated. And we know where the function call origination was, a function call, by looking at the return address in our frame. So this is why we kept track of it. We need to know where we go back to. For a simple example like this, you're probably thinking, wow, Chris, did you really need to write that down? Well, pretty soon we're going to see some programs that will have multiple function frames added before they start to return back, and keeping track of all those details is really hard for us to do without externalizing that state of our program in a memory diagram. So we're going to jump back to the origination of the call found in the RA of our frame, the return address. And what happens when we do this is we are evaluating function call to whatever we wrote in RV, right, to our returned value. And I'm just going to separate this out just a bit. All right. So this is how we get into a function call. Steps that happen before this. We prepare the function frame. We jump into the function call definition, the body. We move through its statements until we reach a return statement. And when we reach a return statement, these are the steps we take to get back to where we came from. Well, let's bring this diagram home. And I'm going to jump back to code to finish this program out. All right, so we just finished line 14, and now we reach line 15. We print Z. Well, what is Z? Well, remember, we need to look in what is our current frame, and our current frame is always going to be the last frame on the stack that has yet to return. So this frame is returned, right? We're done with my max's frame. But the globals frame, it doesn't really return anything, and it's like the last place we'll check. So we check here, and we see that Z is 7, and our output would be 7. When we reach line 16, we've reached the end of our program. There's nothing else for us to do, and we've completed this program. So a few notes I want to make before talking about some details you need to know about the return statement specifically. First, what we're doing in memory here in our diagram is very closely related to what's actually happening inside of your Python interpreter while your program is being evaluated. There are actually more details going on under the hood than we're keeping track of, but these are the essential details we need to know in order to trace our programs. As we're getting started in this course, you're going to recognize that, man, this feels like a lot of work for what seems like a simple program. Like you could easily have done this in your head. We did it in our head, right? Without drawing all of this out. Well, we learn these steps and we practice this diagramming technique right now in order to prepare us for some of the concepts that are much harder to understand if we don't have a very sound understanding of the model of how the machine is interpreting our programs. So we'll have you'll come back later in the semester and be very thankful that you've mastered the skill of diagramming in this way in order to better understand some of the more difficult concepts in programming, such as recursion, such as values versus references, and some other ideas that you have no frame of reference for now, but we'll get to. All right, before bringing this home, I want to just mention a few details about the return statement that are worth knowing and driving home and emphasizing, because the return statement is different from any one you've seen prior. So the return statement syntax is the return keyword followed by an expression. Now, as we've already seen, the expression needs to match the type of the expression. Return statement expression needs to match the return type specified in the function signature or the function contract. Function definitions, return type. All right, so this is fundamentally important. And this is how we make sure we write validly typed programs and that we have our functions are going to behave as we advertise them and adhere to their contract. All right, so the return statement's expression must match the function definition's return statement. Right? If we have a function that declares a return type, such as int or string, our function body must reach a return statement that will return a value. So each function with a return type must reach a return statement when called. All right. The third thing we need to know is that when a return statement evaluates, the function call's job is completed. So when a return expression or a return statement evaluates, the function call is completed. And this makes sense. It's pretty obvious in the example we just had, but I want to modify that just slightly to prove that this is true and to give you a sense of why this is important to understand. So I'm going to jump back to VS Code and I'm going to encourage you to follow along with this. Now, as we mentioned when introducing if-else statements, we don't have to have an else branch. We can just have something that comes after another statement after our if branch. And so now we've changed the logic of this little function, right? If A is greater than B, we're going to return A. And then after that if statement, we reach this return statement for return B. So let's imagine that we are evaluating this program. I'm not going to do this with the complete memory diagram. Let's just follow along intuitively because I want to focus on what happens with this return statement. All right. So let me clear out my diagram. And let's imagine that we had assigned to A, let's say A was once again 6 and B was 7. Okay. If A is greater than or equal to B, well, A is 6, B is 7, that's false. Right? So we don't hit this return statement, we just return B. Right? And we would return 7, and that's the last statement in this program. Makes sense, this is done. All right. So no change in what we had done before. But let's imagine what happens if we had actually flipped X and Y. So let's imagine that we had instead called my max of YX, right? So that would have evaluated Y, which was 7, to be passed to the A parameter, and it would have been 7, and B would have been 6, okay? So now what happens? Well, this is where things get a little bit more interesting and where we have to be very careful with our understanding of the return statement, right? So if A is 7 and B is 6, this is true, right? So this statement is true. And so we go into the then block and we hit this return statement, right? We return A. Well, what's A? A is 7. Now, based on what we just learned, this is the end of the function evaluation, right? When you reach the return statement, that's when the function call is complete. We go into the process of running through those steps. Okay, we now write down the RV of 7. If we were doing this in a full frame, and then we pass this value back to where the function call originated, right? Back to where it originated. Notice though that if this return statement didn't behave specially, we should have continued on. There was more left for us to do in this function definition, but we're not going to do that. As soon as you're processing a function's body and you're in a function call and you encounter a return statement, that function job, the job of the function call is completed. You begin working through your return steps, and anything that might exist after that in the function call body, you're going to ignore. It's not going to happen. It might in a different call, like we saw. If we use different arguments, we would get different results here. But as soon as a function call reaches a return statement, that's when you begin the process of the return steps, and then your function call is complete. It doesn't matter what came after it. All right. So this was some great practice with introducing the semantics of function calls and what happens when we encounter them on in our programs. We carry out a common sequence of steps that you'll get very comfortable with. We set up a new frame. We name the frame. We keep track of the return address. We pass in our arguments. We make sure all of the arguments check out. They match up with our parameters. Then we pass them in. And then we jump into the frame. We process the frame, and when we hit a return statement, we go back to where we came from, right? In the next lesson, we'll start looking at more advanced uses of function calls and look at where we can apply these rules, but the application of them starts to become a little bit more nuanced. This is a fundamentally very important concept to become comfortable with. So I'd encourage you to practice this concept and try following along with other function calls and diagramming them out to be sure you understand the steps or the semantics of what's going on behind the scenes.